Hey there, Yorick here. I'm going to talk about security around Ethereum 2.0 staking. This was a request on the channel. It's been a while, taken me a while to come up with how I want to do this. Security is a rather large topic, so you might get bored. We'll have timestamps in the video, so you can jump around and take the pieces you want to take. I think I'm going to tackle this in 3 basic blocks. First, talk about what are we securing and why and from what, and then go into physical security. Second will be security of the node itself, and then third, I'll give some pointers on Windows security for the client to access the node from. Though, as always, that won't be exhaustive. Couple of notes on security to start with. So you start with, what am I protecting here? So obviously, if you're staking, you're protecting your ETH, your money. And then in what way are you protecting it? From what are you protecting it? You're protecting it from theft. You're also protecting it otherwise from loss, from being unable to get at it, right? And you're ensuring that it's available, or that the staking continues and you have the best returns. With Ethereum 2.0, there are 2 components you need to protect. One is the withdrawal key and the other one is the signing key. If you're completely unaware of how Ethereum 2.0 works, I'll put a link in to a primer for that, an explainer. I really can't handle that on this video, obviously, right? So after you generated your validator keys here, these are actually the signing keys. That's over, I hope you can see my mouse cursor, that's over here on the generate validator keys side. These are the signing keys. If those get stolen, the worst that can happen to you is that you are slashed, you have a forced exit, you lose some ETH. Along with that is generated a mnemonic, a phrase that allows you to recover these keys, but that also will be used to create the withdrawal key. That is absolutely, excuse the pun, key. That is the most important part you need to protect. And that actually has nothing to do with the node, and nothing to do with Linux, and nothing to do with Windows. It's all physical security. This mnemonic is a 24-word phrase. So I'm going to repeat this a couple times throughout the video because it's so important to know. Unlike, say, you have a hardware wallet, like a Ledger or a Trezor or whatever it might be, right, where the mnemonic allows you to recover it, where it's a backup, and you can still get at your funds as long as you have the hardware wallet. Here with Ethereum 2.0, without this phrase, you cannot withdraw. So we've had a situation with a very few people, luckily, and let's hope that stays that way, who have deposited, got the validator keys, but somehow managed to forget the mnemonic, or not write it down, or whatever it might be. And that means they can never get at their funds again. That's gone forever. There's no way to recover it. That's really important to understand. The reverse is also true. If somebody has this mnemonic, once withdrawals are enabled, after the merge of Ethereum 2 and Ethereum 1, which previously was called phase 1.5 when we still had phases, after withdrawals have been enabled, anybody with the withdrawal key can initiate the withdrawal, and the withdrawal key is derived from that mnemonic passphrase. So without the passphrase, no access to the funds. With the passphrase, all access to the funds. That's really important to understand. In some way, you can think of this as the passphrase is, in some really real way, that is your staked ETH. Anybody who has it has your staked ETH. So it needs to be safeguarded, right? That's what I'm trying to hammer home here. So what that means in practice is you want to think about theft and things of that nature, and of course also the possibility that you lose it and then you don't have access to it anymore. The first thing to think about here is you really do not want this mnemonic in digital online form anywhere. It should not be in your password manager. It should not be in a file on your computer. right? It shouldn't be anywhere that it can be gotten to on a computer or from the net. The only place it should be is physically in the world, offline. I'm going to talk a little bit about what your options are there. So the first and simplest way to do this is simply write it down on a piece of paper, right? That's basic. Maybe not the most secure. It could burn, particularly if you're in a area that has a lot of burning, where wildfires are common. But it's better than doing nothing at all. So a piece of paper ain't bad. If you want to go beyond that, there are a number of ideas on how to put this into steel. And then the steel plates usually are really good at surviving a burn, surviving crushing, surviving corrosion, those kind of things, and still being accessible. Speaking of accessible, this stuff needs to be accessible to you and your potential descendants. So you should give some thought to where am I keeping this in such a way that it can't be stolen, but also in such a way that my descendants have access to it. How am I putting this into the will? How am I teaching them how to use this thing, right? Do I point them towards Reddit? That might actually not be a bad idea to say, ask on Ethstaker, just don't ever give your mnemonic away. Do I have a video with my will that explains how to use this stuff and where to get help, right? Yeah, it's a real asset, and you want to protect it, not just for yourself, but for anybody who might get it if you are no longer. As with all things security, you will never be 100% secure, and you can always add more security to the idea, and at some point you have diminishing returns where the amount you spend on security isn't worth what you're securing anymore, right? So obviously you can create put this in some alpine bunkers in Switzerland somewhere, but the question is, what's the cost of that? So a couple easy ideas beyond paper are these steel ideas. I'm going to show you three just because I'm aware of them. They seem decent. I'm not saying those are the only ones. There's a gazillion of them. Choose something that works for you, and as I say, if you don't have anything else, start with paper and keep it in a secure location. So I'm going to show you two cassette ideas first. Those are fairly simple. This is Kobo. They're Kobo tablet. So you have the first 4 letters of each part of the phrase here. It can secure a 24-word phrase. And this should be decent for most of your use. They actually have a better version of that now. You see here it doesn't have a whole lot of screws, which would be an issue with crushing. They have a newer version that has more screws in it, so has crushing a little better. Yeah, it's decent as far as cost goes. It's a good entry-level idea, right? Obviously, if somebody has this, they have your phrase, just as with paper. So you'd need to keep it in a secure location where it can't be stolen. Second idea is the CryptoSteel cassette. Similar idea, just maybe, when I look at it physically, it seems a little stronger against crushing. Probably the same with corrosion and fire. Those are usually less worrisome for these kind of ideas here. And they do the exact same thing with the phrase, right? 24 words and just the first 4 letters, which is all you need to recover this stuff. And then the last idea is something that's just on pre-order right now. This is Engrave Graphene. That's a really interesting idea. So this requires more effort. It's more secure against theft. It's a little bit more secure against loss as well, maybe. It does have the drawback of requiring additional steps, which you need to explain to your descendants. So what they're doing here is they have 2 plates. This is the front plate, this is the back plate, and they're taking your 24 words and they're converting that into a hexadecimal code. Then they're going to grab the front plate here, and you see it's here marked from 0 through F, but the way that the front plate is marked is unique. So where these are located on the front plate, where the 0 is, where the 9 is, and so on, that's unique to you, right? And then you just use a hole punch to punch through the back plate, and that marks the code. So what you need in order to recover this is, first you need the upper plate, and Ngrave will remember, if you like, they will remember what the upper plate was. So you can reorder this. You can also tell them to forget it, but that means that if you lose the upper plate, you're screwed. The lower plate, where you punch this into, and then when you combine the two, that's how you get your hexadecimal code, and from the hexadecimal code you can then get the full code. Lower plates are cheaper than upper plates, so you could completely, if you want to go all the way, you could have the upper plate somewhere in a safe, the lower plate in a different location in a safe, the backup second lower plate with the same code in yet another different location in a safe, right? And you will then postulate where these things are and how to put them back together and how to use them. So if somebody, say, breaks into your home and steals an upper plate, well, does not get them anything without the lower plate. Same thing for the other safe locations you have. If somebody steals a lower plate, that's not going to get them anything without the upper plate. Of course, again, this is the important part. You don't want to lose stuff. If you really have a reasonable fear that this will get stolen, then you need a backup location. And it needs to be somewhere else as well. There need to be two lower plates. One that, will not be nabbed with the first one. And I think that's about as paranoid as one might get. Full disclosure, I haven't done this Ngrave thing, also because, I think it's pre-order right now. I'm recording this on the 1st of January 2021. And that's maybe going a little far, but I'm sort of thinking about it. My stake might not be big enough to warrant this, but if you have a decently large stake, this might be worth thinking on. Okay, so I talked about where to keep your withdrawal key and how important the withdrawal key is. Haven't really talked about how to generate it. Depends a little bit, again, on your level of caution that you want to employ here. So when you're generating the validator keys through Eth2 deposit CLI, which is the usual way you do this, Launchpad tells you to use that, right? You're getting the validator keys and you're also getting them mnemonic. It makes sense to do this on a machine that you can trust, where there's no screen scraping going on, there is no keyboard capturing going on. It's basically as secure as it can be. So what some people actually do is they will boot from a live CD, like an Ubuntu or a Tails or whatever you like, some form of Linux live CD. They will then download Eth2 validator CLI. They will disconnect the box from the internet at this point so that there's absolutely no connection to the network whatsoever. They'll generate the keys, they'll generate the mnemonic, they'll write down the mnemonic. Again, it's really important that it is not online in any way, shape, or form. Never store this online, only offline. And then once they've done that, they'll take the validator keys, copy them, say, to a USB drive. Those are encrypted, by the way, with the passphrase you set. And then shut down the machine that they booted from the live CD. After shutdown, everything is lost, the memory is gone, and you can now safely boot this into your normal operating system, and your mnemonic could not be compromised because you generated it while the machine was not connected to the internet, and so nobody could have ever gotten this thing. That's going quite far. You might not want to go that far, but it's not out. It's not crazy either, right? It's not out of the ordinary. Okay, so let's say you've done all that. Your withdrawal key, or rather the mnemonic to generate it, is safe offline in a safe somewhere. You know what you're going to tell your descendants. You're going to totally amend your will to make sure it's in there. Of course you will, right? Just like I have. Yep. And now we're going to get into what I think people actually wanted when they asked me for this, which was, how do I secure my Linux server? So coming back briefly to what are we actually securing here? What you're securing in this case is the validator key, the signing key. So the signing key is used in the validator client to sign attestations and proposals. And the worst thing someone can do if they have two things, they need the signing key and they need the passphrase to it, because the signing key is encrypted. If they have both of those things, the absolute worst they can do is threaten to slash you and try and get some form of ransom from you, right? If you are being slashed because, say, your validator attests twice in one epoch, then you lose, I think, a minimum of 1 ETH, might be a little more, and you will be force exited. And that's it. So it hurts, but it's not the end of the world. Without the withdrawal key or the mnemonic, your funds cannot be withdrawn. So you are still the one who will withdraw the funds. You took a beating, but you're still alive and well, or reasonably well, right? As well as you can be. That having been said, you'd like to avoid this, of course. So we're going to talk a little bit about how to secure your Linux server. And then I'm also going to talk about how to secure the machine to access this all from, which could potentially be even more important than the Linux server. I'm going to do this from a perspective of eth2docker, my own tooling. Some of this stuff will be transferable, a lot of it actually will be, but some will be specific to eth2docker. And I'm going to approach this from a perspective of running this in a cloud-connected VPS. If you run at home, it's very similar, but a couple things will be different, and we'll get to that. That's mostly around firewalling. Okay, I'm going to be using CoinCashew's best practices for eth2 validator security, as well as my own notes in eth2docker. And at a high level, there's a couple of things we're going to do. We're going to create a non-root user with sudo privileges, so that we're not operating as a root on the device and can't log into root as the device. We're going to disable SSH password auth and use SSH keys only. This is absolutely critical for anything that has SSH exposed to the internet. It's desirable for something in your own network, but it's critical for internet stuff. Why is this important? Because with SSH keys, you're using two-factor. Somebody who or some form of thereof, right? Somebody who wants to log in needs, one, the SSH key itself, which is encrypted with a passphrase, and two, the passphrase to unlock it. We're going to talk about blocking and tackling, updating your system. How do you keep your system up to date? This unintended upgrades here, we're actually going to go a little bit deeper than what's being done here. I am not going to disable the root account. Although you could, but I don't have to. And it can be useful to actually have it present for like troubleshooting and stuff. Because the root account won't be able to log in remotely, I'm okay. I'm also not going to set up two-factor authentication for SSH because I'm already using a key. But if you'd like to do this with Google Authenticator, that's actually a really nice idea, and this walks you through how to do that. Securing shared memory. Really nothing wrong with that. I'm not going to do it only because everything's Dockerized anyway, so there's no shared memory outside of the Docker containers that I'm worried about, because everything's in its own Docker container. But again, if you're not running Docker, then this is a good idea. Fail to ban. This is not a bad idea at all. It basically says if we're seeing intrusion attempts, we're going to ban an IP address for like 10 minutes or so, right? Not extremely critical if you are using SSH keys, but if you're using passwords, then by all means this must be in there. And then lastly, configuring your firewall. Yeah, that's really important because I'm assuming we're going to be on a cloud node, so you really don't want more stuff open than it needs to be. And this last part here, using system user accounts, that's actually automated, sort of, with the Docker containers. You do have that least privilege separation. Okay, so I am logged into a fresh VPS here, and as you can see, I'm logged in as a root, and I was able to do this through SSH. That's rather atrocious. In addition, the VPS provider emailed me the password in clear text, so I kind of need to reset my root password for starters. Now, what I should think about is, where am I keeping these passwords? I'm going to get into some ideas later on. Basically, I want strong passwords. They need to be kept encrypted somewhere, and I ideally want this somewhere where that is not cloud connected, if I can make that happen, right? So I might keep this in something like a KeePass, which exists for Linux, for Mac, for Windows, and keep it there, and also use this to create these passwords for me. Ideally, in daily use, when I'm checking up on this thing, all I need is my SSH passphrase, which I make something that I can remember but which can't be cracked, and then everything else can stay in a password vault. So in this case, I'm going to go through KeePass here, show you a little bit how that works. Create a new database. I'm just going to call it database KDBX here. As an example, give it a master password. This should be a passphrase that you can remember and you're not using somewhere else. It's always important not to have reuse. I use little phrases made of several words. That makes it very, very hard to guess, impossible to brute force, and I can't forget it. And we're just going to say this is Eth2. Okay, do you want to print an emergency sheet? So I'm going to skip this here because I'm just showing how this works, but this is not a bad idea. The emergency sheet would be something that's kept with your will in a safe somewhere, right? So this basically says, how do I get at this KeePass database, which you're probably also keeping in the safe somewhere, maybe on an archival DVD or something of that nature. How do I get at it? How does that work, and what do I need it for? Yeah, all right, skipping for now. All right, making a new entry. I delete these sample entries here. So what I first need to do is going to be my root Eth2 account. Username is root. And as you can see, KeePass created a password for me. These will be crypto strong and cannot be guessed. So that's what I'm going to be using here. And we're just going to say, I want to change my password, please. New password. And retype that. Okay, updated successfully. Let's just verify that that worked. So okay, so what I just did is I logged out and then I logged back in with a new password, and that worked. So great, that's done. Next part, now that I have a root password that's not known to my provider, I need a non-root user that I will use regularly. So I'm going to just do add user and say that is Yorick. Okay, I need a password. Same thing again. I'm going to let this thing create a Yorick Eth2 user. I'm going to let it create a password for me that is crypto strong, cannot be remembered, and only exists in this database. And all this I can ignore. I don't need any of that. Is that information correct? Yep. Okay, so that's the user I'm going to use. And now I also need to make sure that this user is part of the sudo group. If you're not using Ubuntu, sudo first needs to be installed, yada yada. So all this assumes Ubuntu 20, by the way. Should have mentioned that earlier. This is so ubiquitous, right? So now Yorick is a sudo user. Good for him. And that user can now completely access everything I need to do. So what I'm going to do is I'm going to log out again, log back in as Yorick, and then I'm going to take the next steps. Okay, I'm back in as Yorick. Yay me, hooray. that means I can now change things so that I can use an SSH key here. Right now I'm still logging in with a password, and even though it's crypto strong, that can be used to brute force it. And crypto strong is hard to brute force, but still. And of course, it's in no way, shape, or form is this two-factor. Somebody who has that password is in, and I don't want that. So what I'm going to do is I'm going to create myself an SSH key pair. I actually happen to already have one, but for the purposes of showing how this works. So while I don't use PowerShell for daily work on this, I'm just going to show how that works in PowerShell, because that might be useful. So I'm going to have this SSH keygen command here and generate myself a key. It wants to save this into .sh. Let's use the default and enter passphrase. Don't leave this empty. If you leave this empty, somebody with a key can just log in. That's potentially worse than just having a password, right? So we're going to set a passphrase. Passphrase should be different from what you had for the key vault, and again something here that you can remember and that can't be cracked. Okay, there we go. We now have this thing. We now have a key. It's a private key and a public key, and the public key needs to make it onto the device, onto the node I'm going to connect to. So I'm on my client here, I'm on my Windows server, and I want to connect to my Ethereum 2 node. What I'm going to use for that is the cat command, just as if I was on Linux. So cat.ssh id at 25519.pub. This is my public key. And I don't have any problem with showing you this thing because it's the public key, right? Doesn't really matter. So this thing, if I was on Linux, I could now do an SSH copy ID. That actually does not work in PowerShell. So I'm going to have to come back in here, and I don't think I have an SSH directory. I do not. I'm going to make myself a .ssh directory, cd into it, cd.ssh, and I'm going to say I'm going to use nano just for you guys. Nano authorized _keys, and put this key in here. Control X, save, and do that. Okay, so next steps. I'm going to attempt to log in from over here and see how that works. So I did that. SSH Yorick at IP address. Authenticity of host can't be established, which is expected. Permanently added it to the list of known hosts. Enter passphrase for the key, which I just did. Hit enter, and I am in. Right? So just like that. So now from now on, I could SSH in all the time with this key, which means I can now turn off password authentication. Okay, so by the way, if during this step, instead of being asked to offer the passphrase for the key, you're still being asked to offer the password for the user, then something went wrong. Most likely you didn't copy the authorized key into the right location, right? Or you didn't copy it right, or something of that nature. Okay, so next step, I'm going to turn off password authentication. I'm also going to turn off SSH root login. But in this VPS in particular, root login was allowed, so I'm going to turn that off. This is where sudo comes in handy, so I'm going to edit the file etc ssh sshd config. That's this command right here. Let's do that. So I need my password for the user here because I'm going to do sudo. Okay, there we are. So we're going to go look for something with root. Permit root login? Yes, absolutely not. Right? We don't want that. So that's gone. And then the second is password auth, I think like that. Password authentication? Yes. So I'm going to change that. Password authentication? No. Okay. Exit. Save modified buffer. Yup. And then the next part is, now that I've done that, restart the SSH and then test, right? So restart SSH. Okay, I'm still logged in here. And now I'm gonna go test this. So you see here, I opened another window, just did SSH root at IP address of the device I'm trying to get to, my node here, and I get permission denied public key. That's precisely what I want. Now one more thing that I can do here, and you could be of two minds about that, is I'm actually going to make the Yorick user here, the non-root user, I'm going to make it part of the Docker group after installing Docker. Do I want this, right? That's a good question. So on the one hand, once I've done that, somebody with access to the user Yorick can, without any difficulty, get into Docker, which means they also have access to the signing key. So that might be a concern. If I don't do that, then they need sudo first. Okay, that's an additional step. That sounds more secure. But on the other hand, that also means I need sudo every time I do something, which means there are many more moments where I will get this sudo password on my client and then input it here. So how worried am I about that? Right? It's a good question. I think ultimately what I have to think about is if my client is compromised, the one I'm coming from, then they most likely will have both the SSH key and the passphrase for it. So I'm kinda up the creek, the proverbial one without a paddle. At that point, whether they get my sudo password or not is almost immaterial. Don't get your client compromised. If there's better ideas for safeguarding that, please do let me know. I intend to save this KeePass thing on the encrypted password database on a USB key that is itself encrypted and unlocked with a hardware token. So in that way, I'd really prefer to not unlock it if I don't have to. So I'm going to make this user part of the Docker group. Also makes life a little easier on day-to-day operations. But I can see where you might say, I'd rather not do that and I'll just tap the sudo password whenever I have to. Either way, I think. Okay, so if I want to make this part of the Docker group, obviously Docker needs to be installed. So I'm going to do that first. Here are the prerequisites. So I'm just going to run these one line at a time here. First the update and dist upgrade, and then the install for Docker, Docker Compose, and Git. I probably already did that previously, or they did it for me, not sure. So that was my apt update, and now let's bring Docker in here. Okay, so now that I have Docker in here, I'm going to do the same thing I did previously to put this user in, create this user, and make it part of the sudo group. And I am going to make it part of Docker. Which reminds me, side note, that might have been a good thing earlier. The reason I manually created a user here is that my VPS provider didn't. But if you install, like say, an Ubuntu server or desktop, by default, there will be a non-root user already that's part of the sudo group. Just use that. You don't need to create another one. So I'm going to use this command here, just that now I obviously need sudo because I'm not a non-root user. So I'm going to go sudo. This might actually not work. I might not be able to modify myself. Let's see, Docker Yorick. Survey says, no, I could. Okay, great. So I'm part of the Docker group. Let's try it. Docker ls. No, I have to log out. Let's log out and back in. 1 second. All right, logging out and back in is so that Linux can understand that I'm part of the Docker group. There's probably a quicker way to do that, but this typically works. See, Docker ls. And okay. Wow. Okay, that was an interesting one. As you see here, Docker was actually down. I was convinced it brought itself up after installation, but apparently not. Also says Docker service is disabled. Should be enabled. Something's really not quite right. So I'm just gonna reboot this right quick and see how it behaves. Okay, that was a little unexpected. I had to sudo systemctl enable my Docker and then start it. Alright, so now I have Docker running. Really not expected. It should have done that during the install, but yeah, who knows. Moving on. So I have that system for reasonably secure login. A couple more things that matter from a security perspective, though maybe not, traditional security, if you so will. I also have to think about, is my validator actually validating the way I want it to, and am I getting the best response out of it, and it will not stop validating for me. So that's availability really in the security matrix, right? So here what I need to do is I need to make sure that my time is decently synchronized. By default, Ubuntu actually does this. Time date control will use NTP, and that's probably good enough for most setups. But because of reasons, I'm going to switch this over to the NTPD service. So I have multiple servers I can pull from, which makes the timekeeping a little better. I'm just going to install NTP. Now when I run time date control, it should tell me that the system clock NTP service is not running. That's as expected. And I want to see that I have NTP peers, NTPQ-P, and I have these NTP peers going on, so that's looking good. Okay. Now next, my OS itself, the Ubuntu that I run my node on, it will need updates, and this will run for years, and I will not want to babysit this. So I need unattended automatic upgrades. That's important, right? So let's get that done. Also part of security, if not maybe what you're thinking of when you're thinking security. So I have a link to that over here, enable automatic updates. That's what I'm going to do. I'm going to start with installing the unattended upgrades package. You see I do a lot of copy paste to save myself some typing. Okay. And then I need to edit the file for it, the configuration file, and make some changes. So most importantly, I actually do want these updates here, not just app security, infra security. I want the actual updates to the OS. So delete these comment lines here. I'm going to go down a little bit to mail. So I'm going to put in a mail user here and a mail report. This is going to be, instead of on change, let's say only on error. And for the mail to work, obviously I'll need a mail package as well, which I'll get to in a second. I won't show you how to install that, but I'll give you an installation instructions that I'll link to. I'm going to change this so that it removes unused kernel packages and removes new unused dependencies as well. Automatic reboot. Actually, yes, I think I will do this. Again, because otherwise, if it needs to reboot the device, the node, and it's not set to automatic, then this will wait until I log in, and again, this will run for years without supervision potentially, right? Or minimal supervision. Since there won't be any legitimate users in here other than me when I'm doing maintenance, I'm going to say reboot with users is fine, and then 2 a.m. is fine. I should change that. Give me one sec. I was just thinking about time zones and whether this thing uses a time zone or it uses UTC. I'm not quite clear, but still this is fine. Okay, I think that's everything I care about in here. I'm gonna write, exit. Okay, so wrote those changes. And then I'm gonna have to actually set the upgrade intervals. So I'm gonna edit this file here, the auto upgrades file, which in this case is actually empty. So I'm gonna grab these and put them in there. If that's not empty in your environment, just have these lines and set them to whatever you want. So package lists and downloading is done every day. Auto clean interval is done every 7 days. Unattended upgrade is done every day. And save that with Control X. And now this suggests to do a dry run, so I'm going to do that right quick and see how that behaves. And this looks good. Lastly, for email notifications to work, if this fails, there's instructions here which are linked from over here as well, the email you link here. I'm just going to run through this here right quick. There's stuff in here that obviously I don't want to show you, such as my authentication password, but it's a fairly simple setup here for SSMTP, and that's just for outgoing mail, just so that the box can mail me if something goes wrong. If you are using Gmail or something of that nature, this example here assumes it, but it could be any other service, and you're using two-factor authentication, which you really should be, then you'll need an app password here, because obviously this Linux server can't two-factor. I've got this note here about setting up IPMI. If you don't have a VPS and you're running this at home in a entry-level server, then that's what you would do. But on a VPS, that's not really important. So I now have just to recap briefly, I have a non-root user, which might already be the default depending on your VPS provider. It's part of the sudo and the Docker groups. Docker is installed and running, which took a little bit more effort than I thought it would. I have SSH set up to disallow root login, to disallow password login, and I have an SSH key to log into this thing. Obviously, if I lose my SSH key or the passphrase to it, then I've lost access to the server, and I'll need to get in through the console on the VPS provider, right? Which is still possible, but a bit of a pain. So, as always, these things should be backed up, secured somewhere where they're safe. Yeah. So an additional idea that CoinCashew has here is to install fail2ban. Search as log files or mark as log files, and then if it looks like there's a repeated pattern of failed login attempts, it'll lock somebody out. That could be yourself, right? But we can just do a 10-minute. It really shuts down the idea of brute forcing anything, even though we already disabled password auth, so this isn't entirely, shall we say, necessary. I'm going to go for it anyway. Doesn't hurt anything. So let's install fail2ban and then edit the config file here like the CoinCashew is suggesting. And this is a whitelisting idea here. Since I'm coming through the internet from a dynamic IP on my provider, there's really nothing I can whitelist. This is more for a thing locally. And then we're gonna just use this thing here. Oh wait, that didn't work. Let's try this again. Wow. Okay, apparently Nano doesn't like copy paste as well as I might like. So I'm just gonna use VI. Yeah, random port number. So you may have noticed I didn't give SSHD a random port number. You can, if you like. It just means you have to, type that every time you connect. I'm thinking between password auth disabled and using key auth and fail to ban, I'm really not too worried about SSH being on a well-known port. Sure, 22 gets hammered, but you know, what are people gonna do? They're not gonna get very far on it. So, and restart fail to ban. Okay, let's just do a quick look to see that that's actually enabled on reboot. Yes, it is. It's fail to ban service enabled. Okay, that's looking good. Okay, the one remaining part here is to set up a firewall, and that really depends a little bit on where you are. If this is a system inside your network, UFW firewalling is nice. You probably want to set it up. You don't have to go very far with it, right? You can set UFW to allow your SSH port, disallow everything else, UFW being the user firewall on Ubuntu, and let Docker take care of the rest, because Docker will open dynamically the ports that are being mapped to the host, and I'll show that a little bit what that looks like. On a VPS like this one, it really depends. Some VPS providers have a security option, have security protocol, basically a firewall, a network firewall. AWS is one of them. So if you're using a provider that has these settings available, you can just use their firewall to firewall your VPS and not rely on the methods you have available on the VPS itself. This can be easier to manage, just because it's graphical, easy click mouse, you're done. If you are doing this, however, on a VPS that's wide open to the internet, like the budget VPS I'm using here, for example, you'll need to make sure that although Docker likes to open all the ports, you close down ports again. So what I'm not going to be able to do here, I think, is explain to you what a port is. That gets a little far, but if you don't know, please look it up. If you're unclear as to what a firewall is, what an IP address is, what a port is, go look that up and learn it. Welcome to the world of being a validator operator. Now you become a sysop and security expert and a network person. So briefly, what ports might I be concerned about? So obviously I got SSH. I need to allow that in, no matter what. I got this sync with other beacon nodes here. These are peer-to-peer ports, so I want that one. Eth1 peer-to-peer ports, I want that one, no question. But over here, reporting package, that's one of the most common ones I'll want to block. So if I'm running a Grafana, so I have some nice reporting going on, right, and I have something graphical to look at, by default it runs on port 3000. My project currently does not stick this behind a reverse proxy. It's one of those to-do things that I never seem to get to. So this we need to disallow. So now you might say, well, that's a VPS. I just disallowed access to the Grafana port. How do I get there? Good question. You'll get there through SSH, and I'll show you that as well. And then lastly, that depends a little bit on how you're setting things up. If you have a standalone Ethereum 1 node that's being referenced by multiple beacon nodes, this might be a situation where you have, say, a lighthouse running, you have a prism running, and a geth, and the prism says your failover beacon node in case there is a catastrophic bug in lighthouse, right, so that you have a fully synced node ready. In that case, with that failover node, you will want to make sure that the Ethereum 1 node itself, this connection here, where the beacon node fetches from Ethereum 1 node, that this connection is not available outside to the internet, and it will be by default. So you'll need to firewall that as well. Let's take a quick look at these ports. So these are your peer-to-peer ports here. 3033 would be your Ethereum 1, whether that's a geth, Open Ethereum, Besu, Nethermind, don't really care, right? 9000 by default is the lighthouse. 13,000 and 12,000 is the prism beacon node. 9,000 again default Teku. 9,000 default Nimbus. These are all the peer-to-peer ports. Whatever client you're running, that can be open to internet. This is fine, right? 22 TCP, SSH. This will be open to internet if it's a remote server, a VPS, which we're running here. And then 3000 TCP, that's Grafana by default. That's HTTP, it's not secured. There's no traffic or Nginx in front of it. So you do not want this open to internet, and by default it actually will be on a VPS if the provider for it doesn't have their own network firewall. No worries, however. So I'm going to start by allowing SSH in on UFW. I should say this is only for the default port. If you changed your SSH port, put your SSH port in here, right? But I'm just going to say allow open SSH because I'm on port 22. I haven't changed that. And then I'm going to do a quick show added. So I'm going to make sure that I have this right. Okay, I'm allowing OpenSSH, and I'm going to enable my firewall. Now I should point out, if I got this wrong and I don't have this OpenSSH here, by enabling UFW I would actually cut off SSH access. So say I say allow OpenSSH, but I actually put SSH on some higher port, I don't know, 3598, whatever, right? Because I'm that paranoid. And I just did this OpenSSH thing here, allowing port 22, well, I would have just cut myself off. So take some care with this step so that you're not locking yourself out of the device. And it's warning me about that, and I say yes please. And as you can see, I'm still good. And I'm going to do a status numbered. Okay. And that's all she wrote here as far as if I'm not on a VPS, right? I'm done at this point. Or if I'm not running Grafana, I'm done at this point because I'll just have the peer-to-peer stuff. But if I am on a VPS with Grafana and or maybe a shared Eth1 between multiple beacons, and that could be my main lighthouse beacon or my main prism beacon or whatever it is with a backup beacon. It could be sharing this between a rocket pool and a standalone staking, whatever it is. Whenever I have a shared Eth1, because of the way that Docker works, that port, that Eth1 port, will be mapped to the host and thus on a VPS to the internet. So I need to cut that off and only allow communication from other Docker instances and not from the internet at large. Okay, so I'm gonna show you a setup where I have Lighthouse with Grafana running. I have Ethereum 1 running, a Geth in this case, and it will be shared to another, it will be a standalone shared to the Lighthouse, and I'll have a Prism as well, but without Grafana. And the Prism will be my DR setup. So I'm just gonna clone my eth2 docker here, and I'm gonna say this. Let's say this is eth2 main lighthouse, or just eth2 lighthouse, like that. Okay, yep. And then this will be eth1, and then I want eth2 prism. I'm gonna say dr, so when I do this, I remember that that's my DR setup and I don't make any silly mistakes, right? Okay, so this is my .env. I verified that my local UID is 1000. If I only have one non-root user, that'll be the default. My compose file is geth.yaml eth1 standalone YAML, so that'll make it available for other stuff. eth1 nodes here, this is for beacons, so I don't touch that. Network mainnet eth1 network mainnet, actually not used for Geth, but I'm setting this as a reminder when I look at it later. And then Geth1 network girly is commented out. Side note, eventually maybe this won't be needed, but for now, until this is fixed upstream. Okay, so if I didn't make any terrible mistakes, I should now be able to start Geth. And it built the image and started Geth for me. Let's just see how it's doing. And as a reminder, I made myself part of the Docker group. That's why I don't need sudo here. One or the other, which is more secure, who knows. Docker compose logs eth1. Let's just see that Geth is happy. Seems to be reasonably happy. It's running things. Okay, and let's do a quick docker ps. Okay, so see this bit here, ports 00085458546, 8545 being HTTP, 8546 being a WS, and then of course 3033. Now 3033 is fine, TCP UDP. This will now be open to internet. While UFW doesn't know about it, Docker does, and Docker has opened this up, right, in IP tables. UFW actually backends to IP tables. Now that makes any sense, don't worry too much about it, but you can dig into that rabbit hole as to what is IP tables on Linux. It's the actual firewall. UFW is a easier user mode, easier to use way of managing IP tables entries, and it has its own what are known as chains. And okay, I'm going too far. I get it. Whatever. So UFW is the kind of the easy-ish way of interacting with the firewall, and IP tables is the deep down where we're getting into the nitty-gritty, and Docker automatically modifies IP tables. So all this is open. When 8545 is open, what I've seen is on a VPS, almost immediately I get hammered with some random connections that are trying to get into potential accounts on Eth1 and trying to send transactions on Eth1. Now obviously I don't have any accounts and transactions set up here, but still, yeah, that's not nice. I've seen it crash open Ethereum, so that constant hammering actually acted as a DOS. Geth in my testing hasn't crashed, but again, you want this closed, right? So you want a situation where Docker can get to it, but nothing else. Okay, so in my instructions, I have this little link here. Please take a look at notes on cloud security. Okay, let's click that. Here's the rabbit hole. So now what we're going to do is we're going to place UFW in front of the Docker stuff. So that will execute first. By default, first it's the Docker stuff, and then after that comes UFW. That's why whatever I do in UFW doesn't really impact Docker. But we're going to do this the other way around now. We're going to do that by placing UFW into the Docker user chain. And that's the chain that Docker has if a user wants to create additional firewall ruling, right? So bear with me. This is a little bit of surgery here. So we're going to take the UFW after.rules. Here they are. And we're going to leave all of this alone, including this commit here. Leave all of that alone. Don't make any changes. And then we're just going to add stuff to it. Paste. Okay, I'm going to go through that quickly. We're looking at UFW user input, which is the input chain on UFW, and Docker user, which is the Docker user provided chain. I'm going to allow all inter-container traffic. So the idea here is all I want to do is I want to disallow traffic coming in from the internet to my VPS, right? I'm not interested in causing issues with the container to container stuff. So I'm still allowing Docker to manage all that automatically. So I'm just saying if it's 10, 172.16 or 192.168, then just return. So it'll come back out of that and then go through the rest of the chains, which that's where the other typical Docker chains live, and Docker will take care of this container to container communication. I'm not getting UFW into that. And then after that, only after that, I have my UFW user input, and that's where the stuff will live that will disallow communication from the internet. And then I return. I actually don't need this return, it's implied, but I have it here just to make it very clear that that's what I'm doing. So write that. Okay, so that's my after rules. And then I need my before init. So these were rules. Now I'm gonna do something that executes before UFW gets started, and we're gonna in stop. We're gonna do this stuff here. Explain what all this does. So paste. So we're clearing the Docker user chain. We're not stopping UFW, right? We're clearing the Docker user chain. We're adding just a return to the Docker user chain, and we are getting rid of the UFW user input here. This is absolutely necessary. If I don't do this, then on Ubuntu, in my testing at least, UFW cannot be reloaded. So I can load UFW once, but if I stop it and start it, it'll fail, which obviously I don't want. So what else do I need to do? I need to make this executable. So we're going to do a little change mod here. So this is executable. All right, perfect. And now we're going to reload UFW. Okay, now I have a standalone Eth1 on port 8545, and it also lives on 8546. So arguably maybe I need to make this a little bit better here. This example. So I'm going to allow I'm just allowing 172.16.00.12 here. Now, only because in my testing that's where Docker was living. But if I want to be very specific, very precise here, I really should also do this for the other RFC 1918, because Docker can take from any of them, right? So 192.16, that one as well. And then let's say we're going to do 10.0/8. Okay. And then lastly, we're denying from anywhere else. Okay, lovely. Now, I could repeat this for 8546. That's the WS port. The only client that currently uses that is Nimbus. So since I am not going to use Nimbus in this setup, I'm just going to deny 8546 entirely. But if I needed that WS port, and I'd do the same thing here, UFW allow from any port 8546, etc., 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 and then deny. So here they are. So now take a look at this, status numbered. Here are my rules, right? I'm allowing OpenSSH. I'm allowing 8545 from, okay, I'm allowing it from the Docker source, and it just, I need to test this some more. This should actually work without these specific rules. We'll see how it behaves. Okay, so this is the env for my lighthouse I'm going to set up, so I can test that this is working. Just LHBase and LHGrafana. You see I don't have a geth in here because I'm going to point to it. It's going to be HTTP, then the node IP, so what's local on this device. This also happens to be, in this case, the public IP of it, right, because it's on a VPS. And then network mainnet, Eth1 network mainnet, just for documentation purposes. I'm obviously not running an Eth1 in this directory here. And yep, let's take a look at that. So now that this is up and running, I can see my Grafana is up on 3000, so I'll have to contain that. I've got my 9000, that's my peer-to-peer ports. Those can stay open, no problem there. You see here these ports on Lighthouse for the beacon. These are the metrics ports and the port that the validator connects to. You see these aren't mapped, right? So that's fine. I'm not worried about these. These are in the Docker Compose network or the Docker network, however you want to view that. And they're not mapped to the host and thus not to the internet. So I'm really only concerned about this bit here and that part here, the Grafana. And so when I am looking at the logs for the beacon node, I see that it's telling me here it's got an issue with the Eth1 HTTP server. But the reason is, where are we? All fallback errored, endpoint error far behind. So that's good, right? That means it's actually working the way I want it to. The reason it's complaining is that Geth is far behind. Not surprising, I just started it. It's not complaining because I can't get to it. Obviously, if this were a production thing, I could, with Lighthouse, I could have a comma-separated failover. With Prism, I could have failover as well in a different way, just not comma-separated. And so I could failover to, like, say, an Infura or an Alchemy. I think I'm remembering why I'm putting those rules in there. It has to do with how Docker does network address translation, NAT, which it does under the hood when it does this port mapping. The default Docker rules somehow don't cover a container going out to talk to another container via the host, but they do cover traffic coming in from the internet at large. I never really got deep enough into why that is, but I know how to secure it, so that's good enough for me for now. So port 3000. I'm going to do that with SSH tunneling, which means I'll have an SSH connection open, and I will tell the SSH connection that anything going to localhost on my Windows machine to 3000 should pop out and then go to a destination 3000 on where I am. And now in this particular case, because I am on a Docker, I'm not going to have it pop out on localhost. If you have this running on bare metal, your SSH would pop out on localhost again, right? You get always the SSH tunnel will work the way that you would access it from the node itself. So I'm on this node here, on this VPS. If this was, if Grafana was running directly on the metal without Docker, then I would access Grafana as localhost 3000. But because it is on Docker, I'm actually accessing it as the node IP 3000, in this case the public IP. So that's what I'm going to tell SSH. Okay, short excursion there into SSH tunneling. So what I want to do here is I want to allow traffic coming from localhost to port 3000 because that's where it's going to be sourced from when it comes out of the SSH tunnel. Fun. Okay. Why? One sec. Not sure what I did. Probably something with me monkeying with stuff, but a quick UFW reload fixed it. So UFW allow from localhost to port 3000, and then I'm going to deny 3000 on anything else. If I can get my syntax right. Now you note I'm being a little lazy here. I'm just doing port 3000. Strictly speaking, it's 3000 TCP, but it really doesn't hurt me, right? It's not like I'm gonna try and reach this through UDP anyway. Okay, so if I want to get to this, what I'm gonna do is SSH 3000 to the node IP 3000, and then user at node IP. So what this does is, with the -L tunnel, what this does is I'm saying, when you get 3000 locally, stick that into the SSH tunnel, and then once it comes out of the SSH tunnel, send it to the node IP 3000. Okay. Moment of truth. Does this actually work? All right, let's try it. HTTP 127.0.0.1.3000. Not 172. 127. And here I am. Here's my Grafana, right? Another really good reason to firewall this is, of course, by default, I don't have a password set. So, yeah, anybody could have put in a password here. Same procedure as before. You'll have these passwords set up securely and kept somewhere. So, Should see that that worked. It seems fine. Lighthouse summary. Okay, and nope. There's my Lighthouse summary for the running client. Right. I'm not going to set up a Grafana for the Prism because that's going to be a backup only. But the same thing would apply. If I have that on, say, a 3001 or whatever, then I'd firewall it the same way. If you stuck with me until here, kudos. I know that's a lot of stuff and not everything went super smoothly. So quick recap. The most important thing you're safeguarding is your mnemonic, because that is your stake. Without it, you cannot access it, and with it, anybody can claim it once withdrawals are enabled after the merge. And the second most important thing is just the node itself, and we went through a couple of Linux security things on how to, do basic Linux security and make sure that logins are two-factor with SSH key, and you have decent firewalling on there, and auto updates, and good time sync and things of that nature. Okay, one more thing about the security of your node. So I haven't mentioned the validator key on there. You also have the password for it most likely on there in plain text. It is in a Docker, but obviously the user can get to it. If somebody were to steal the device, if it's in your home, they would have access to that. Securing against that is difficult. There are a few ideas. You could have an encrypted file system that does not require you to input a password when you start, because you also need this available, right? You have these auto reboots and all that going on while it updates itself, so you don't want it sitting there and not validating. TrueNAS Scale may be a way to do that. That's a Linux-based, pretty damn good NAS system, and that has ZFS and it's got auto encryption built in. But that's a whole different learning curve about ZFS. In a nutshell, you want this stuff because it's a database on a mirror of SSDs. Not RAID Z2 or RAID Z3, not HDD, none of that, right? An SSD mirror. So that's one idea. The other idea is to go into a remote signer and then actually have the remote signer be in something like a AWS Micro. I have not included that in the project as of right this very second in January, but it's definitely on my mind. So that's advanced security. If you're really worried about, is the physical machine secure, right? Or can I trust the provider I have it with? Then you could put this into somewhere else where you trust them more, like an AWS, maybe with the AWS secret management. As always, there is no such thing as perfect security. The fact that the validator needs to know the key in order to be validating something means that theoretically this key can eventually be stolen. The question is just how much effort would it take, and is it worth anybody's while to try and do that? Okay, so with that said, I know this has been a question as to why are people so chill with the password just being on there? What if the machine gets physically stolen? You'd have an issue, right? The larger issue might actually be that somebody just fires that thing up while you're validating somewhere else on a replacement machine, and then you get slashed. So if there's a real risk that whatever you're running at home gets stolen, then running this in a budget VPS might actually be more secure, because then you can stop worrying about all that. Okay, so lastly, now that we've got all that handled as well as I could, let's talk about the client security a little bit, the client you're coming from. So in my case, that's Windows. That might be a Linux, it might be a Mac OS. You're really just using it to SSH into the node. That's all you're doing, right? And you might have your KeePass there. That's where you keep all the really important passwords. This is a broad subject. and I'm really just gonna give you a couple ideas, and I may be hectoring you a little bit here. So obviously, if the security of the machine you're coming from is compromised, really all bets are off. Sure, you're keeping the withdrawal key offline and in a safe somewhere, maybe even in steel. That's great, that's awesome, right? And eventually you're gonna want to withdraw. Now, fingers crossed, you're gonna do that again from a machine, when you do the withdrawal from a machine that you can completely trust. Maybe it's a live CD or something like that. That level of paranoia is actually probably really warranted. And you're also using this to access your node and do management. So that means it needs to be reasonably convenient. You can tighten security to the point that it becomes loose, right? Kind of like you can over tighten a screw and then it strips. If you make security so tight that you're not going to use it because it's too much, and you then just do workarounds or whatever, then it's too much, right? So you gotta have enough to be reasonably secure, but not so much that you can't handle it on a day-to-day basis when you need to check your node. Okay, so that having been said, a couple ideas. One idea is, this is a bit of a pain. You just don't trust your day-to-day computing environment because of whatever behaviors you have on there. And so, your user behaviors, I'm saying. And so you have a dual boot. You boot into Linux or something, and that's what you use to access your node, right? Or maybe you have a separate machine that you're using only to access your node, and it's not used for any of your other browsing and emailing. Bit of a lift, but very secure. It might be worth it if you have enough at stake to just say, I have this little machine here, over here, that just runs SSH to get in there, and that just runs a browser to get to Grafana, and that's it. I'm not emailing on it, I'm not gaming on it, I'm not browsing the web on it, I'm not watching exciting videos on it, I'm doing nothing like that, right? That's that's about as secure as you can get, and if you have enough at stake, it makes sense to do that. Now, if that's not where you're at, then the best advice I can give you is most attacks against Windows clients in particular, and Mac OS and Linux are less attacked but have somewhat of a similar issue. Most attacks come from users actually installing the malware. You might say, I would never do such a thing. Well, it happens through the web, it happens through downloads, and it happens through attachments and email. So in the web, it might be you're going to some site that is, shall we say, not quite so savory, and it pops up something that says, your machine has been compromised. Click here to download a scanner. Well, guess what? The scanner is the actual malware, right? Or you're saying, I don't want to pay for this program, or I don't want to pay for this video. So I'm going to use a cracked version, or I'm going to go and torrent something, right? I'm going to get this PDF, I'm going to get that video, and then they're telling me, oh, you need to install that codec to watch it, and I do that. All of this carries incredible risk. Anything pirated, you can pretty much assume that it carries a highly elevated risk of bringing malware into your machine. My own Windows machine, I haven't had malware for over 10 years. I'm probably going on 20 now. Because once I had kids, I completely stopped pirating everything. I was just like, how can I tell my kids to be honest people and keep pirating shit? It doesn't work. So I stopped, and lo and behold, malware stopped. Simple as that, right? On email, it's, if you didn't ask for that attachment, it's no good. If it's something like, hey, you got this is USPS, right? You have a package waiting for you. Click on this PDF. Yeah, good, nice one. They don't send that kind of stuff. They don't send me PDFs, right? So that PDF is spiked. It tries to exploit something, and it will install malware, right? So, how do you keep a Windows machine secure? Become that stick in the mud that doesn't pirate. that goes a long way. It goes an amazingly long way. Patch, and patch some more. And then lastly, sure, you can run an antivirus, but understand, antivirus is a losing proposition. These antivirus programs, all of them, only really good ones, the heuristic ones, they catch a fraction of the viruses out there. If it gets to antivirus, you've already lost. If that catches something, great, but most likely if it gets to that point, you've already lost. A couple other ideas that I can link here that I've had in the other videos is how to create a encrypted USB key on Windows, and maybe how to set up a Windows sandbox environment, right? The only thing is, you still need to communicate with the sandbox, and you need to type things into the sandbox. So while the sandbox environment helps you with not getting infected in the first place if you're going somewhere, it doesn't really help you if you're already infected, because the keylogger will log on the host OS, not in the sandbox, and there you go. Okay, I think that's all I had. So once more to recap, keep your mnemonic safe. It's everything. Do some basic security around Linux, and you gotta be able to trust the client you're coming from to access your node. And if that's where you are saying, well, I can't really trust my daily driver because I do all kinds of stuff on it, then maybe you need a separate machine just for node access. All right, thank you. I hope this was helpful.